Example 3. Now we talk about a parametric equation. Different idea. To be honest, most students are able to do Cartesian. Most students are able to do Cartesian. But when it comes to parametric, a lot of us are not very comfortable. But you must be okay. You must be comfortable. So now we have parametric. Interesting thing is there's an A irritating. Cannot use GC therefore. Find the equation of the normal at P when T equals to 2. Wow. Now it's difficult. This idea is difficult. But never mind. Let me just use a simple diagram to help us. Simple graph. Actually, I don't know how this graph looks like. Don't quote me. I really don't know. So anyhow, like that, whatever. Actually, I don't know. I really don't know. Okay? What do you want? Suppose this point P, I also don't know where is point P. Suppose P is here. Suppose. What do you want? You want the gradient, or rather you want the equation of the normal. That means this is tangent is like that. Normal is like that. This is normal. Correct? You actually want this equation. Follow? Before we can find equation, we need gradient. We need the gradient of this straight line. To find gradient, we must find dy dx. Correct? Before we find the equation, we also need the coordinates of this point. That means, what is this? We need this. But they didn't give us, they only gave us t equals to 2. Later we find out how to get these coordinates. So we must begin with the end in mind. First, we must find gradient. Next, we must find coordinates of the point. Begin with the end in mind. Now, okay, so gradient. How do we find gradient for parametric? We must first find the x dt and dy dt, then take this, divide by this. Am I right? Follow? Okay, let's do this. How do you differentiate this with respect to t? The a is a constant, don't be scared. Okay? A is a constant. Differentiate 1, you get 0. Differentiate t to the power of minus 1 is what? You bring down the minus 1, and then t to the power of minus 2. So which is actually minus 1 over t squared. Got that? Similarly, dy dt, this is t to the power of minus 2, right? So you get a, you bring down the minus 2, you get a 2 over t cubed. Oh, sorry, there's a t, sorry, here. There's a 1. My bad. There's a 1 plus 2 over t cubed. Sorry, there's a t. Oh, differentiate t, you get 1. Next. What do we do? Recall, I'm just going to write along at the side. Can we recall how to find dy dx? If you recall, no need to copy. But if you don't, better write. Dy dx is actually dy dt times dt dx. Am I right to say that? So dy dx is this. Dt dx is 1 divided by this. Correct? Follow? Remember? Can you remember? Dy dx is dy dt times dt. These two, as if these two cancels off. Alright? So what is dy dx? T is this. Which is, therefore, this color. A 1 plus 2 over t cubed times, if you write this, it's actually 1 over this, right? Correct? It's 1 over this. So you get 1
over minus a divided by t squared, which is now what do I do? This one very hard to simplify. What next line? If you all can do faster, then just go ahead. I'm going to combine these two as a common denominator, which is t cubed. So I'm going to write it like that, which is a t cubed plus 2 over t cubed. Okay? Times. Now, this will be t squared over negative a. Correct? This is 1 divided by this, the reciprocal, you just bring the t squared up. Then you realize that t squared becomes t. Yep. Then your final answer is your, and then your a also cancel, sorry. Your a also cancel. What you end up with is negative t cubed plus 2 over t. Okay? Don't know how many equal sign, no need equal sign. Okay, okay. Okay, that. Now, remember what we want now. We give the n in mind again. Now let's look at this diagram again. This one. Our objective is to find the gradient of that normal. Now we know that the gradient at any point, if I know the t, I will know the normal. I will know the equation. If I know the t, I will know the gradient of the tangent. Correct? Now, at t equals to 2, I will know, I substitute t equals to 2, I get the gradient of the tangent. You clear? So, at t equals to 2, but before that, sorry, and I also need to find these two, right? At t equals to 2, at this point, this is at t equals to 2, what is the x coordinate and what's the y coordinate? I need to know these two. So, if you're fast enough, let us very quickly go through this. Thank you. X equals to what? Y equals to what? dy dx equals to what? Our objective is to find x coordinate, y coordinate, and the dy dx. Substitute, and you will know what to do. Okay? Very quickly. Just move on faster than me if you can, okay? No need to wait for me. Okay, this is brainless activity. Just substitute t equals to 2, you get these two coordinates, these two x and y. Okay? Then substitute t equals to 2, you will get your, into here, you get your dy dx. You will get minus 5. Now warning. Then you're very happy, right? Very happy you actually got a dy dx. Is this dy dx minus 5? Is this the gradient of the normal? Because you want equation of normal. Is this the gradient of the normal? No. Then what is it? Gradient of the tangent, right? Warning, this is gradient of tangent. Since it is dy dx, this one is actually the gradient of tangent. So gradient of normal is not this, it's not minus 5. Gradient of normal is 1 over 5. But now we want equation, which is easy now. Once you know this, you know this, you know this, you just want x equals to x1, equation of normal, y minus y1 equals to m, which is the gradient of the normal, x minus x1. Simplify, you get this equation. No big deal. Next part. Read the question. Look up. Given that this normal cuts the y-axis at point N, find the area of triangle OPN where O is the origin. Okay, you got a diagram there, you got a graph there that help you a little bit. Look at. This is the, can I have attention please? This is this one, normal. Don't bother about the graph of the curve anymore. We're not interested in the curve anymore. We're only interested in the line. It cuts. This is the point N. It cuts the y-axis at N. Correct? You actually want to find the area of OPN. Now P we already know. Do we know that? Okay. Wait, what happened to this? Nothing inside, man. Yeah, we already know this. Am I right? We already know the coordinates of P. So far, so good. What else do we need to find the area of this triangle? What else do we need? You know? Have any idea? What else do we need? You can say half base. Where's the base? If you take this as the base, you got a big problem. Then you don't know what is this height. Correct? I would say I let this be the base and I let this be the height. Do you know what I'm saying? I will let this be the base. This be the base, and therefore this will be the height. Follow? I let this be the base. I let this be the height. Now therefore, I already know the height. Height is the x coordinate of this 3a over 2. But I need to find this. Do we know this? Of course we do. Of course we do. Oi. What happened to that thing? Disappear. Okay, never mind. You all copy already, right? The P. Wait, let me erase some things. Oh, come back. Goodness. Okay, can. Done. Does it make sense that the N has this coordinate? Because when sum x equals to 0, you get y. That means this is the y-intercept. This is the y-intercept. Okay, I think our job is done. Right? Area of triangle. Area is actually half base times height. That means half times base times height. Therefore, answer is 87 a square over 80. You need to make notes, better make notes. This is half base times height. Okay, half base times height. Done.